Today, my lab partner Melina Cholom and I will be presenting on our limiting reagent determination lab. I will be explaining the concept of limiting reagents. Limiting reactant is the reactant that is completely consumed first in a chemical reaction. It determines the maximum amount of product that can be formed. Excess reactant is the reactant that is not completely used up. Some amount will remain after the reaction stops. Its significance in chemistry is in industry and labs. Controlling the limiting reactant is crucial for maximizing yield, conserving expensive reagents, and controlling the reaction rate. So here we have a short video of sodium carbonate solution and copper 2 chloride being mixed. And for a little background explanation, the reaction is a double displacement reaction between copper 2 chloride and sodium carbonate. The goal was to react a known total mass of a copper 2 chloride and sodium carbonate mixture completely, and use the mass of the solid product, copper 2 carbonate, to determine the percentage composition of the original mixture and to identify the limiting and excess reactants. After mixing, there was a sort of blue-green precipitate. So here we have a short video of sodium carbonate, copper 2 chloride mixture being dissolved with distilled water. Here we have some pictures of the filtered and unfiltered substance, and to deeper explain, filtrate is the liquid that passes through the filter paper after the solid product is collected. Pure solutions. Copper 2 chloride ions give this solution a blue-green color. Therefore, sodium carbonate ions are colorless in solution. Next, implications of filtrate color. If the filtrate is blue-green or is a blue-green color, it indicates that copper 2 ions are still present. This means that copper 2 chloride is the excess reactant and sodium carbonate was the limiting reactant. If the filtrate is colorless or clear, it indicates that no copper 2 ions remain. This suggests that copper 2 chloride was fully consumed, making copper 2 chloride the limiting reactant and sodium carbonate the excess reactant. Here, as you can see, we have a copy or snapshot of our data table.
So yes, the identification of the limiting reagent by color of the filtrate accurately predicted the yield of product, and the percentage yield for this reaction for trial 1 was 99.9%, and for trial 2 it's 100.2%. Yes, it does have a high yield, and I think one way that yield might be improved is for us to use the vacuum filtration for a better recovery, and also to dry our product thoroughly before weighing. So for the girls' percentage yield of 115% might have occurred because of product not fully dried, filter paper residue, or also contaminants like sodium chloride and sodium carbonate trapped in precipitate. So the effect that is expected to have on the student determination of percentage yield is pouring too fast, accidentally the mixture bypasses the filter paper, or loss of precipitate which lowers the actual yield. This is all the analysis question that I have answered. Thank you. If the limiting reagent was copper 2 chloride, the color of the filtrate would be white or clear filtrate. So to predict the color of the filtrate for these two questions, if it's a blue filtrate, the excess is copper 2 and sodium carbonate is the limiting. If it's a clear or white filtrate, the excess it would be sodium carbonate and the limiting would be copper 2 chloride. So the limiting reagent for the first trial is copper 2 chloride and the excess is sodium carbonate, and the limiting reagent for trial 2 is sodium carbonate and the excess reagent is copper 2 chloride. Good afternoon, Mr. Dyron. My name is Molina Chalam, and I'll be answering the analysis questions based on my results. Firstly, I'll be defining a list of words and state its relevance to this lab activity. Solubility: the ability of a substance to dissolve in a solvent. Its relevance to this lab determines whether copper 2 chloride and sodium carbonate form a precipitate or stay dissolved. Theoretical yield: the maximum amount of product expected based on stoichiometry. Its relevance to the lab is used to calculate percent yield and assess reaction efficiency. Limiting reagent: the reactant that is completely consumed first, limiting product formation. Its relevance to the lab identifies which reactant controls the amount of precipitate formed. And we have excess reagent. The reactant that remains after the reaction is complete. Its relevance to the lab helps confirm which reagent was limiting and explains filtrate composition. Precipitate: a solid formed from a chemical reaction in solution. Its relevance to the lab is the visible product formed when copper 2 chloride reacts with sodium carbonate. Lastly, percentage yield is the actual yield divided by the theoretical yield times 100. Its relevance to this lab measures how efficient the reaction was in producing the expected product. In the image above shows the balanced chemical reaction for the combination of copper 2 chloride and sodium carbonate including the states. The type of reaction that occurs when both solutions of these two compounds are combined is a double displacement precipitation reaction.
In conclusion, the experiment successfully used of a double displacement reaction to determine the percent composition of a copper chloride and sodium carbonate salt mixture. The reaction produced the insoluble copper-2 carbonate precipitate as the measurable product. By passing the collected copper carbonate precipitate and applying the mole ratio from the balanced equation, the mass of the limiting reactant in the original mixture was calculated. Observational evidence from the filtrate color also supported the analysis. The clear filtrate in trial 1 indicate that all copper ions were consumed, confirming copper chloride as the limiting reactant for the trial and yielding a composition of 54.4% copper chloride, with an average overall composition 44.9% copper chloride and 55.1% overall 55.1% sodium carbonate. The trial, the trial in which copper chloride was limiting provide the most accurate determination of its percentage in original blend. The result, however, showed a significant discrepancy between between the two trials, indicating a challenge in experimental precision, particularly in trial 2, which had a faint blue filtrate. This blue color confirmed copper chloride was in excess, meaning the mass of the precipitate in trial 2 was limited by sodium carbonate, leading to a low calculated copper chloride percentage, which is 35.4%. Potential sources of systematic error that could affect the accuracy of the precipitate mass include incomplete drying, which inflates the mass, or incomplete transfer or washing, which lowers the mass or introduces soluble impurities. Ultimately, the lab achieves its primary goal of demonstrating the limiting reagent concept and its critical role in quantitatively analyzing the composition of a chemical mixture.